The next topic is parallel adder with accumulator. So you know that parallel adder is a circuit that does the arithmetic sum of two binary numbers that is greater than 1 bit in length by operating on the corresponding pairs of the bits in parallel. So in computer circuits, there is a frequent desire to store one bit number in a register of flip-flops and add a second number to it, leaving the result stored in the accumulator. One way to achieve this is to add a register to the adder. Okay. So this is a structure of your parallel adder with accumulator, which consists of n registers. So here the register used is your D flip-flops. Okay. So you have, what are the signals you have? You have your, instead of load, there is a signal that is called as AD. It stands for add, CLK for clock, and your clear. So the add signal will be connected to the clock enable. Okay. So when this add is equal to 1, your clock will be enabled. CE stands for clock enable. Now the clock signal is a positive trigger. Okay, there is no bubble, so it is positive clock pulse. And third one is your clear signal. So if you want to make your output to all to be 0, register content to be 0, then you can use a clear signal. So the clear signal will be negative, that is logic 0, because there is a bubble. Okay, so these are the three important signals. And here one of the important feature in this parallel adder with accumulator is that you have a cell which is a combination of a full adder and a register. Okay, so full adder, so this will be one cell. So similarly you can add n number of cells together. Okay, so the two inputs to your full adder will be your x1 and y1 with a previous carry. The carry signal will be forwarded to the next full adder, just similar to that of your full adder operation. For example, if your input is equal to 1 1, then what will happen? Sum is equal to 0 and carry will be 1. That carry will be forwarded to your next full adder. It goes on. Okay, so this is your structure of your parallel adder. So what is the use of this parallel adder? It does your addition in very fast manner. Okay, it is very faster. So how does this operate? So suppose if you have x is equal to, the data input is equal to x1 comma x2 etc up till xn. Similarly y is equal to y1 y2 etc up till yn. So what will be your output of your full adder? Full adder output will be equal to, adder output will be equal to x plus y. So this is going to be your adder output. So whenever you have your add signal is equal to 1, the clock will be enabled and the output that of the full adder, that is your x plus y, will be which is your S1, sum will be loaded to your register or your accumulator. Okay, when? During the rising edge of the clock, because it is a positive clock. Okay. Now, if Si is equal to 1, if your output Si is equal to, sum is equal to 1, what will be your next state? Next state will be equal to 1. Similarly, if Si is equal to 0, your next state will be equal to 0. So these are some of the important concepts in this parallel adder circuit. Now it is an iterative structure where you have, as I have mentioned before, it has an identical cell. So what is your cell? Cell is a combination of your full adder plus your flip-flop. Okay, so this is your typical cell. So this is your working principle of your parallel adder with accumulator. So there is one more alternative circuit which can be used, that is called as adder cell with multiplexer. So this is your block diagram. The same previous diagram is being replaced by your block diagram where you have your clock enabled, your CLK, your clock signal, and your data and your output. Okay, Q. Now what is the only difference? You are going to add a multiplexer. Here a mux is being added. So what is your mux in this case? 2 is to 1, right? So you have 2 inputs and 1 output here, and both your add signal and your load signal is connected to your OR gate. So how will your OR gate work? If any one input is equal to 1, okay, you will be getting output as 1. If both the inputs is 0, you will be getting it as 0, output as 0. So it is A, B, Y. Okay. So your add signal will always be equal to 1. Here you have two options for your load signal. One is 1. It selects, the multiplexer selects either 1 or 0. Right? If it is 1, so here there is an option that it can select directly. Your data can be loaded, can be your input data YA, or it can be a sum. So what will happen when load is equal to 1? If 1 is selected, the 1 will be getting or taking the data input, that is yi, directly, and it will load to the register. Whereas if load is equal to 0, what will happen? It will take the sum of the two inputs, that is the full adder output will be loaded to the accumulator. So this is your working principle of your adder cell with multiplexer.